Hello, 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 hello. So I hope this is working. So if you guys could give me a thumbs up in the chat if you can see me and hear me. So let me know if it's all working. One thing I've noticed that this software does is that sometimes it'll pump up the volume and then it starts getting distorted. So let me know if that's happening and I'll try to adjust it. Anyway, thank you guys for joining me here today. I know that didn't give an end time for this event, but it's not going to be very long. It's only going to be maybe 20 minutes. So good to see you guys. Hello, Brett. Hello, Sebastian. Hi, Kale. Who else is here? Do is here. Noah's here. Hi, DC Sound Up. Thanks for sharing my post. That was cool. Good to see you guys. Hi, Brett. Cool. Looks like things are working. David says it sounds fine. And David says it came in super loud and distorted. So I do have a feature where I can turn off whatever kind of Okay, so now I've turned off whatever kind of compression it's trying to do. Maybe the signal is still too hot. Sorry to spend some time on this. I would hate to listen to this recording later and find out that it's like just check. Okay, so that is with the automatic mic adjustment off. So let me know if that sounds better to you guys. Deuce says a little bit distorted, so I can keep turning it down. I'm not sure what it's doing in the software. Oh, you guys say that it's better. Okay. So keep letting me know in the chat, and I will check in occasionally. I don't do a lot of live streams, so I'm not great at like constantly observing the chat, but I will check in on it occasionally when I can remember. Okay. So, should we high pass everything? Let's share my screen. So, I know this is kind of tiny, and I think if I zoom in here, oh, it does zoom in for you. Okay. So, maybe I can make this even bigger. How about like that? Does that look good? Okay, great. Looking good, sounding good. So here's the situation. I was talking to a new user of SubAligner, and we were going through his system setup, and he opened up his compass settings for me, and they looked like this. And he's got, like an X40 and a 750, something like that. If you're not familiar with Meyer Sound products, that's just a point source speaker and a sub that they have. Pretty simple system, and I saw this processing that he was doing, and I said, hey, what's going on with this? Why do you have the high-pass filters and the low-pass filters on there? And he said, oh, that's just something that I always do. That's why I'm making this video, because as much as I've talked about this in the past, I still discovered that this happens pretty often. What do I mean by that? So let me tell you a story. Imagine that a man is traveling along a road, and there's a fence in the road. And he says, oh, there shouldn't be a fence here, so I'll take it down. Somebody else is with him, and he says, well, if you don't know why the fence is here, that's precisely why you shouldn't take it down. Because you don't know what the consequences of those things are. You don't know who built the fence. People don't just go around building fences. Fences don't just erect themselves by themselves. And I think a similar story might be, let's say that you bought a house, and then you're driving up to the house, and you see, oh, there's no fence here. I want to be more secure. Right? So you say, let me add a fence here. I see a lot of other people adding fences. So you add a fence, And then maybe it so happens that the person who built that house is there. And they say, wait, why did you add a fence? If you go farther down the road, you'll see that there's already another fence. Or maybe there's like an underground fence, and now you've ruined the underground fence by adding your fence. So these are all sort of related discussions to the topic. But these stories all come from this, Chesterton's fence. Have you guys ever heard of this? Chesterton's fence? This is the story that I was just telling you about. It comes from an author named Chesterton from a book from a while back, 1929, a book called The Thing. I haven't read the book. I've only read this article. I'm familiar a little bit with Chesterton's fence. And that's the story I just told you that sort of reflects this idea that anytime we are taking action on a system, it would benefit us to understand how that system is set up and what were the decisions that were made that led to the current state of the system. Another situation that you're probably familiar with is that you come into a sound system that somebody else has set up, and you see that you've got a speaker here and a speaker there, and you start asking, well, why is this aimed like this, and why is this placed like this? The person who set it up is not there. It's hard to figure that stuff out, so you're really limited in what information you have for making these choices. So getting back to audio, I see this and I see a risk. I don't know if it's right or wrong yet, but the first thing I want to talk about is how you can answer this question for yourself. But let me give you just a quick demo of where we're heading. So imagine that you've added this high pass and low pass filter to your outputs without thinking about it too much. You just think, oh, that's just something that I always do. It makes sense, right? I should be getting rid of all that low end. I don't need that. I'm combining it with a sub. I'm protecting my mains. Like, there's a lot of reasons that make sense just on their own for why you might do this to a speaker. But it's the question of then combining them, or what is the decision that led the manufacturer to not just always add that, right? So now when we look at the result combined here, this is the result that we get when we add those filters. Okay? So if you want to put a dollar amount on this, then imagine that this is a $10,000 sound system and you just removed, about an octave here. So you're throwing $1,000 out the window, maybe, or a $100,000 sound system, maybe you're throwing $10,000 out the window. So should the client ask for their money back, or $10,000 of it? I don't know. So this is like a worst case scenario, right? But the first thing that I want to make sure that we talk about is not about, I don't want this to be about who's right and who's wrong, or shaming anybody for choices that they've made. I more just want to talk about, the main thing I want to talk about is how you could answer this question for yourself, so that if you forget everything that we talk about today, you'll have a way of figuring it out again. But I also just want to talk about, why maybe some of these things were the way they are, or why do people still go around saying you should add high pass filters to all outputs and things like that. So this is what we're going to do today, and it shouldn't take that long. We'll see how quickly we can get through it. All right, let me check the chat. Exactly. So here's an example. So David says everything should be high passed, right? And this is the kind of generalization that we want to discuss today to see if that is really the case. And let me get rid of that picture. How do I get rid of this thing? There we go. Now you can see the whole screen. So how can you answer your own questions? So I already have this demo set up here, but I want you to be able to do this. So you can get this really great, really helpful piece of software called Map 3D that you can download from the Meyer Sound site. And as far as I know, it's still the only piece of software available that allows you to set up a complete sound system and then run through all of your system calibration procedures and basically do an end-to-end practice from setting up a sound system to deploying it and calibrating it. It's the only piece of software that I know that allows you to do that. If you have some other suggestions, maybe you could put those into the chat, and that will help other people out, because we all need a place to go to answer our own questions and to practice this kind of stuff. Now, of course, it doesn't have everything, right? Like, you're not practicing rigging, electricity. There's lots of stuff you can't do, but there's lots of things you can do. So I want to do this from scratch because I want you to be able to follow along with this and do this yourself. So I don't know if I need to close this one, or I can just go ahead and make a new project. Okay, so here is a blank project, and anytime you want to say, what would happen if I added some filters to some speakers and then combine them, you can open up a blank project like this, and then we can go through the steps together. Now I'm just realizing that I have some things open here that I should probably quit to save on some memory. Okay. Hopefully that'll help. Okay, so we open up a new document like this, then we can switch to the top view, make things a little bit easier, and then we could just insert two speaker models that we're interested in combining, or if you just want to play around with filters, then you could kind of just pick anything. But in this case, we are going to look at the example of a X40 with a 750, because those were the two models, if memory serves, that this SubAligner user was sharing with me. By the way, I forgot, since we're talking about high-passing everything, I've got my high-pass everything cap on from PA of the day, so thank you, Todd, for that. Okay, let's insert a loudspeaker system. So we go down to individual speakers. We already have X40 here. It's the first one that we picked. And now we're just going to adjust the X, Y, and Z coordinates here. So this is X is 0, Y is going to be something like 2. I think we're in meters here, so actually 0.3, and Z is 0. And I'm going to put that on the layer. Now, what I often do before I even get started here is go to layer management and just add several layers and then name them things like main and sub, or audience and stage, or things like that. This can just be helpful out of the gate to get things going. And now I can go back to the properties for that guy and change him to main. It can also be helpful to go ahead and name your processor outputs, and so we might call this X40 or main and sub, something like that. 750. So now I'm back over here on my object settings. Instead of saying something kind of not ambiguous but not as clear, it just said channel 1, so now I know that, okay, this is my X40. Heading back over here to the model view, let's go ahead and put in a 750 individual loudspeaker. And what's nice about Map 3D is that all of the subs and stuff are here at the top. Okay, so I'll put that on the sub layer, and I'll put that on the 750 channel. Command 0 to zoom to extents, and then I basically just want to bump these around till they are right next to each other. So maybe I can make this 0.2, and then maybe I can make this negative 0.3. That's probably good enough. Okay, so let's insert a microphone so we can have something to measure. Let's go out to about 10 meters at least. We could go out to 100 meters, 1,000 meters for this exercise. 10 meters is probably fine. So I'll give you an example of what this looks like from isometric view. So this is what I had before, right? So we've got this guy, our sub, and then our microphone. And it might be nice to put that microphone on our last layer. No reason, especially, just so I can hide it and show it faster. And now we can call this one mics. Okay. Let me check the chat. Cool. Great. Okay. So once you have just a couple of sources here set up, you can see the reason that I'm doing this is to remove variables. One thing that I see people do a lot of times when they're trying to test something new is insert a bunch of different information. I see this a lot when I see people testing SubAligner for the first time. So people open up SubAligner, they'll go into something like this, and they'll immediately start putting a bunch of different values in here. Well, let's say that this is like 12, and this is 13, and this is 100, and this is 20. And I'm like, are you going to have any idea what those results are when they come out of the other end? So if this distance is 16 and this is 20, then what do you expect the delay to be? Well, if you don't want to do a bunch of complicated math, just start by setting all of these to 1. So it's a similar thing here, right? If you want to, depending on what you're trying to study or what question you're trying to answer, you want to try to simplify everything and eliminate all other possibilities. So don't come in here and make 20 different arrays with all different models of speakers and a bunch of different locations, and it takes you 10 hours to make this design, and all you wanted to answer was, what if I insert a filter on this speaker? So we're trying to eliminate some of those different questions. We don't want to answer a question about distance, so we're putting these equidistant from the microphone. Okay, so as simple a test as we can think of to just try to replicate a situation and answer a question. By the way, if you're just joining us, we are answering this question: how do you answer your own questions? So what we want to know is, what happens if we insert a high pass and a low pass filter on these speakers? And before we do anything, it might be interesting to see, well, let's go ahead and insert the filters first, because let's say that we are in Chesterton's fence story, and we have come up to this fence in the road, and we've said, hey, there's no reason for this fence to be here. Let's take it down. That's akin to putting up a fence. That's akin to adding some filters. So here we are on channel 1. We will add a high pass filter at 100 hertz. Here we are in channel 2. We will add a low pass filter at 100 hertz. I don't really know what I'm doing. I'm not looking at the orders or anything. I'm just adding filters here. These are the 2 default filters that were in the drop downs. So if we go back to the overview, you can see, I think this is where we started our story. Now we have a high pass filter and a low pass filter. I can't remember if I put this one. So they're both at 100 at least, right? Yes. Okay, great. And so we say, great, let's see what happens with that. So we go to our measurement viewer. We auto set delay. We turn on some smoothing. We zoom in on this amplitude graph. And we see, aha! I don't think this is the result that I want. And now we could go down the path of talking about how we know what the result is supposed to be, right? We should have some picture in our mind of what the result is supposed to be before we take any measurement, some assumption we want to prove or disprove, but we're pretty sure that we don't want to be just missing a whole octave of our sound system here, or have this, 8 dB dip in the frequency response. This seems like probably not the result that we want. So then if we were just trying things out, we say, okay, we tore down the fence in the road, and now there's a problem with it. Okay, well, let's put the fence back up. So let's undo what we just did. So we'll bypass and bypass. And then we take a look at the measurement viewer and we see, oh, summation. The problem's gone. Okay, so maybe there was a reason for that fence in the road. Maybe there was a reason that there's no high pass filter automatically inserted when you, select a preset for this speaker. I've used the word preset, but I haven't shown you what I mean by that. So you guys are familiar with the modern functionality of amplifiers and speakers where you often get a speaker, get your amp, and then you combine them, and all you have to do is select the preset. This is how things work in L-Acoustics, D&B, and that makes things really simple, because then if you just load their preset, you guarantee that you get all of the processing and everything that they recommend for that speaker. So Meyer Sound has a similar thing. I'm going to go ahead and open Compass, because that's a little bit more clear here. So in Compass, you can add a processor, then you can make it virtual, then you can head over here. And main thing I'd want to show you is that just like you load presets in other manufacturers' amps, you can also load an Ultra X40 preset here. And you see that there's no starting point. So as far as I know, this preset does nothing, right? It's basically just a confidence booster to let you know that if you are using other speakers with the PC63 standard, that they guarantee that you will be phase aligned. If you don't know about all this stuff with Meyer Sound, don't worry about it. That's not what this presentation is about. My point is only that you can load presets for speakers in Meyer Sound, just like you can load presets for other brands. They're just called starting points here in Meyer Sound land. And the point I was trying to make is that when you load the X40 preset, there's no high pass filter here. And there's probably a reason for that. So let's investigate that a little bit further. Back to the story about the fence, it would be like if that person came up to that fence in the road and said, oh, I wish I knew where this fence was here. And then they go and they call that person, they find that person. Or maybe there's a plaque on the side of the fence that says, this is the reason for the fence. Going back to my question about walking into a sound system, I always wish there was more documentation about sound systems. I've never come into an installed sound system and said, hey, why is this and this and this like that? And what's the password for that? And how do you operate this? And how do you turn that on? There's never any documentation. It's always in someone's head, and maybe that person's there or not there. But I digress. What were we talking about? I can't remember. How to answer your own questions. Okay, so here we were in Map 3D, and we were trying to figure out what happens if we add these filters. We discovered that we added filters, and that actually created a problem. And so now we're wondering what's going on with this Meyer Sound product. So one way that we can do that is by looking at the documentation. We could also just contact Meyer Sound support. We could contact somebody that knows about Meyer Sound stuff. But I just opened up the user's guide here for this Ultra X40, and I just searched for the word filter, and it says the audio processing includes electronic crossover, correction filters for phase, frequency response, and driver protection circuitry. Okay, let's see what else there is. That's something else, and I think this is the same thing. The audio signal is processed with electronic crossovers and correction filters. Okay. So now I'm starting to understand, thinking about the person who built this speaker, thinking about the person who put up this fence in the road. They've thought about this already. They didn't leave it for the end user to add a high-pass filter to protect this device for all of the reasons that you add a high-pass filter to protect a mechanical device and maybe make it work with other speakers. All these reasons, they've thought about all that stuff. And that doesn't mean that maybe I don't have some other special reason why I might add another high pass filter on top of that. But it means that now I've done a little bit of due diligence, a little bit of research to see what are the consequences of my actions and the consequences of those actions. What was the thought process behind the electronic design and circuitry and crossover and filters already present in this device before I started taking action on it? What is the state of this system and how did it get there before I arrived? And I realize a lot of this stuff can be complex, but if I could give you a simple takeaway or heuristic from this event, is that with modern speakers, a lot of this stuff is handled for you already. 9 times out of 10, I go into, at this point in my life, probably 10 times out of 10, I show up and I set up speakers and I don't add any extra filters. I do my normal EQ and calibration tasks, but I'm not adding high pass and low pass filters because the filters are already in there to protect the device. And many times, if you have 2 speakers from the same family that are designed to work together, they're already designed to work together, and there's nothing else that I have to do. So my recommendation is that you approach these situations less like there's a lot of work that you need to do to protect the devices and make them work, and more like consider the fact that the manufacturer has probably thought of a lot of this stuff for you, and all you need to do is learn about how they recommend that you deploy it. Okay, let's take a look at the chat. So, question from Devin. Let's see if I have an answer for this, Devin. Does the high pass not being applied in the software by manufacturers apply to mains only? I know many modern engineers will put it on to reduce on-stage buildup of low end. Yeah, so I think the point is just that you take responsibility for the filter that you're adding, right? So if you understand the effects of the filter in terms of its, gain reduction on the magnitude response, phase shift on the phase response, group delay, and then, combining with another speaker, you're taking responsibility for that, you know what you're doing, then yes, you can start using filters. In the case of stage monitors, probably they're not being combined with another sub unless it's a fill or a drum fill or something. So you have a little bit more leeway there, right? Because you're not worried about this low end lining up with another piece of low end. You're basically doing multi-channel mixing. When we're building front of house sound systems, a lot of times we're sending the same signal to the entire system, maybe. So all of those sources are coherent, and we really need to be careful with any phase shift that we introduce, any latency that we introduce. We need to have complete control over that. Our job as sound engineers and system technicians is to manage interactions between all these sources. When it comes to stage sound, now we have a bunch of independent mixes. So even though you might have 2 speakers right next to each other that could cause interference, maybe you're sending them completely different materials. Maybe it's only guitar in one, and maybe it's only vocals in one. So in that, I think it's a little bit easier. If you need to roll up the high pass filter on all of your speakers, you can. I don't have a lot of experience as a monitor engineer, but my experience typically is that I don't do that. I just use high pass filters on channels. But you should talk to somebody who has a lot more experience. If you're here watching this and you have experience being a monitor engineer and using using high pass filters on outputs to speakers, please feel free to chime in to Devin's question there. Okay. And Francisco says when to use the Galaxy starting points. I would say always. I think they have been pretty clever of the implementation there, right? And I haven't been to a Meyersound training in a while, so I am not the official answer to Meyersound questions. But they've done some interesting things there where, for example, even though, do I still have Compass open? Even though the X40 Or let's say something else. There are other things like a Lena and a 750, right? Lena and 750 designed to work together. When you load the Lena starting point and the 750 starting point, they don't do anything. But I would say always load them, because otherwise you have to remember that they don't do anything, and that's okay, but it's just nice confidence. Now I know, hey, I load the X40 preset, and if I load the presets for all my speakers, now I have confidence that I basically done my due diligence as a sound engineer to do the thing. And it's possible in the future that Meyer Sound might update those starting points. And then as long as you have the practice of always loading the starting points, I don't know. For me, it feels like a good idea. But again, I'm not necessarily an expert on the Meyer Sound products. Okay. So let's keep going here. So we talked a little bit about how you can answer your own questions. Map 3D, Room EQ Wizard, Crosslight, places where you can put in your stuff, practice playing around with filters, practice doing your work, and have some idea about what the results will be if you get into the field tomorrow and add a filter, right? Okay, so what's wrong with high-pass filters? Well, we talked a little bit about this Chesterton's fence analogy, right? Like we're taking action on a system that somebody else has already set up. We are taking action on a speaker that someone else has already built. We haven't built that speaker. We don't know all the decisions that went into it. So we want to try to understand that a little bit. And let me just, or actually, I'll save it for the very end. For the very end, I want to read you just this last paragraph. It's really good. So what's wrong with high-pass filters? Well, there's nothing wrong with them inherently, right? They're super useful. We use them all the time. There are definitely some things happening with time smearing in the time domain. So if you go to YouTube, or let's just type in Nathan Lively high-pass time machine. Oh, I can't even find my own videos. Okay, I'll link to it later. I have a video called Highpass Time Machine, or at least I thought that's what it was called. Apparently it's not. But in that video, I show how the impulse response changes when you add different kinds of filters. So that's a question. But in our day-to-day world of just using products, there's nothing wrong with high-pass filters. There's nothing wrong with low-pass filters. As long as you know what you're doing and you're taking responsibility for them, you can change them. So let's give the example of Meyer Sound here. Now we just saw that we can combine this X40 and this 750, this main and this sub. They're designed to work together out of the box. Another reason that I know that is because if I get out of here and I go to adding subwoofers, then this says, let's see, then this says if I want to add a subwoofer to my X40, they have built-in crossovers. Subwoofers can be added by simply daisy chaining them. So there's no special processing whatsoever. So I don't even need a Galileo. I don't even need the starting points. I don't need any output processing. So that's another reason why I know that if I just take off all of the processing, that these two speakers will work fine. And that's another reason why when I saw this person had high-pass filters and low-pass filters, I thought, I wonder what's going on there, because Meyer Sound says that these two things shouldn't need anything extra. So in the world of Meyer Sound, almost every crossover alignment is an overlap crossover, so you get summation. I think that's the result that we've seen here, right? So we're getting a bump here. So what do you do about that? You can just easily EQ that out. Where do you EQ that? So you could either do that symmetrically on each channel, so put the same filter on your main as you do on your sub. You could do it on a group. You could do it upstream in the inputs. if you can, put EQs into EQs or groups into groups, however your output processor works, you just want to make sure that the final result you get is hits the target that you want, basically, right? You don't want to accidentally put one filter on your main and another on your top, and then you've created a misalignment. So whatever you do, just make sure that it's symmetrically applied to both channels. Yeah, so in Meyer Sound, typically we combine two things. As long as we're using the correct way of using those products, then they should be phase compatible, and then we get this overlap crossover that we EQ out. Or I believe the common Meyer Sound teaching is that you can change the low pass filter of the sub. Maybe that's changed since then, but what's interesting is that they point out that you can do that, but again, you're taking responsibility for that change. So I think that becomes clear if you open something like the starting point for the 750, and you open the starting point, and there used to be a little pop-up. You know what? It's probably not popping up right now because, there it is. Can you guys see this? It says, modifying the high-pass filter and the low-pass filter settings will result in different PC standard curves. AKA, if you change the settings, now you're responsible for it, right? Like, we're not taking responsibility. We're not guaranteeing phase compatibility anymore if you start introducing custom settings, right? Okay. Okay, so let me check the chat. Okay, cool. So why do people do this? I've done this many times. I got out of college 20 years ago. And around that time, I was putting high-pass filters on everything, because what I learned in recording school is that you should put high-pass filters on everything. And this makes sense in a mixing world, right? Like, I put high-pass filters on all my channels, and I put them as high as possible until it's painful, right? So I think that's one of the reasons, is that, I don't know, it's just a thing that I learned from the recording world, that we're putting high-pass filters on everything. And so then when I got into live sound, I thought, oh, I need to get rid of the low end, right? There's a bunch of noise down there. I need to protect my speakers, right? I didn't know really why, but I thought, like, oh, you have to put high-pass filters and everything. So I think that's kind of legacy behavior. It maybe comes from these days when, maybe passive speakers are being shipped with some instructions or some spec sheet that says, hey, you need to add this high-pass filter. And so all of maybe the filtering and protection was actually the responsibility for that was being placed on the user, right? So if that was required of us for a long time, then of course that's still going to be in a lot of the culture, and every speaker is different. So there's probably still are some speakers that do require that. All of this to say that I feel like I understand why a lot of us still think this is something that we need to do, and oh, I just heard that that's what people do. I see people do that a lot, and I heard this, I overheard it at a party, or I heard it at a training or something. Another thing that Bryce reminded me of that was really funny is, I remember this as well. He was talking about how sometimes you hear like this farting noise of the speaker, like the low frequency driver is like having some weird thing happening, and then you put a high pass filter on it and it sounds better. I have had exactly that same experience. We've all had that experience, unless you're just getting into sound in the last few years, and now there aren't as many speakers without this kind of protection already built in. We've all had this experience of the sound cleaning up, and they thought, oh, okay, I'll just always do this, right? Now I need to always do this. Okay, maybe not necessary anymore, or just at least do your research to make sure you know what you're doing. Okay, I like this question. Other speakers have high-pass filters, but mine doesn't. What I think is going on here, and you guys can tell me if what you think about this. What I think is that maybe in a speaker like the Ultra X40, since it doesn't have any settings on the back, it's super simple, right? You just plug it in and turn it on. Meanwhile, you look at some other speaker that has a dial on the back, and maybe it says like crossover, 80 hertz, crossover 100 hertz, floor monitor, wedge, you know the kind of speakers that I'm talking about. Because that exists, then maybe you look at a speaker like the Ultra X40 and you think, oh, they don't have those settings. They haven't done those settings yet. I need to do those settings. And I think this comes back to Chesterton's fence. You see something missing, you feel like you need to add it, but if you do a little bit of research or you talk to someone at Meyer Sound, you would probably find out that they have considered that. There's a reason that the speakers don't have all those settings. Okay, so now we've talked about this a lot already, but I think that's kind of what's going on there. Is that sometimes you might look at a professional product, and this is what's sort of interesting, right? You look at more of the prosumer brands and they have a lot more buttons and switches on the back. You look at the bigger, most expensive speakers in the world and they have almost no settings. You know, you load the presets for, I think like a Cara or a K1, and there's like 1 or 2 presets, right? And then you get to the cheaper speakers and there's a bunch of different presets because they need those to combine with a bunch of other brands, and there needs to be more options. And it's this interesting, stuff about the world of speakers and business that I don't quite understand. But I think that's part of what's going on there, is that you don't see a crossover switch or a high-pass filter switch on the back of the speaker, and you're comparing that to some other brand speakers, and so you're thinking, oh, I need to add that. Totally understandable, right? Totally understandable. And that's what all of this stuff is. It's all totally understandable and also potentially unnecessary and also potentially destructive, as we've seen. So I'm going to do one last check of the chat, and then I'll just wrap up with some final thoughts about taking action on people's systems and adding high-pass and low-pass filters. Okay, the chat. Okay, I think I got everything. Sebastian says RTFM. Yes, very true. Okay, great. I think I got them all. So I do want to share with you a quick way of adding filters if you feel like it's necessary. This is covered in the SubAligner's user's manual. The reason that I want to say this is because I feel like I sound very negative anytime I give these kinds of presentations. I'm basically saying, you're doing it wrong. Stop using filters. Of course you can use filters when you kind of understand how to use them. If you go to the SubAligner user guide and you jump down to one of these last questions, can I modify SubAligner results to reduce the crossover bandwidth? You could say the exact same question about this situation here. Can I reduce the summation between these two sources and therefore the bandwidth? Let's get back to our sum sort. There we go. Can I reduce the summation and the chain, modify the crossover relationship between these two sources myself? So I'll give you one shortcut for that. And I should preface this by saying you should learn how to use filters. I have a couple of classes about it. So if you go to Sound Design Live and then go to the training section, I have one called Intro to the Phase Graph and the Phase Alignment Science Academy. So I'll put those in the chat. There's lots of other great videos and trainings out there about filters. So hopefully you can find something that works for you. Okay, so back to this question. Is there a quick, easy way, once I know that these two sources are aligned, to modify that relationship? And so what I suggest in the user's guide for SubAligner is that yes, as long as you use symmetrical filters with an even order. And so we look at this table and we see, okay, orders 2, 4, 6, and 8 with these slopes. As long as I use those with these polarity settings, then I can get away with adding filters and not really knowing much else of what I'm doing. So let's just do a quick test of that, and I hope that nobody's mad at me for trying to simplify this too much. But again, I wanted to feel like you have some agency and you can add some filters when you want to. Again, the simple way to solve this problem, if you don't like this, maybe this is perfect for you, but if you don't like this, the simple way is just to, apply whatever EQ is necessary to remove this. But if you wanted to reduce this crossover relationship and make the bandwidth smaller, and keep in mind that that's not necessarily a good thing. And keep in mind that that bandwidth relationship between those two sources may already be very small, and therefore maybe it's not a good idea to make it smaller, okay? These are all just different risks that are inherent in this process, but it looks fairly wide to me. 1 octave does not seem very wide. 2 octaves is a lot more common, but let's go ahead and just practice adding some filters to reduce this relationship here. So I go over to my processor settings, and based on this, it looks like I can add 2 second order filters as long as I invert the polarity of one side. So let's go to our output processor. Here is our X40, so we'll add the high-pass filter, and we'll put it at 80 hertz. We should probably talk about how to choose that frequency, but I'm trying to wrap up here, and it could be a whole other video, right? Talking about how to choose the frequency, topology, and all the things related to filters. It's really interesting stuff that maybe we should talk about more in a future video. But here I'm just choosing the default filter topologies. I see that they are second order, and so I'm just going to go over to my sub here, and I'll insert a polarity inversion, and I'll just cross my fingers. Okay, so here you can see that we have reduced summation. Now I should have taken a snapshot before that, but what I'll do is I'll take a snapshot of this, store live trace. We'll call this with filters, and then we'll go back over here and we'll take all of this out. Okay. So here is the difference that we got. These two right here, we can zoom in on this a little bit. Not a lot, but we could keep playing around with that. We just tried 2 second order filters. We could try 4th order, 6, 8. We could try changing the frequency around a little bit. And it would probably be better to have a target trace that we're trying to hit. It would probably be better to be looking at the 2 of these. It would even be better if we were auditioning these and could see what they sound like, right? Because right now we're just playing around with graphs, we're playing around with quantities, but that doesn't really give us a great idea of what the quality is. So if we could have an end-to-end system set up, but not very many people have that. So what I normally recommend is that you come up with a few presets, right? So maybe you find 2 or 3 or 4 things here, results that look good on screen, load those into your processor, and then go out and set up your speakers, and then do, audition your 4 presets. Okay, so that was just my quick tip on an easy way to add filters. And I'll just wrap up with this, this text here that I think is really nice. So Chesterton's fence is not an admonishment of anyone who tries to make improvements. It is a call to be aware of second-order thinking before intervening. It reminds us that we don't always know better than those who made decisions before us, and we can't see all the nuances to a situation until we're intimate with it. Unless we know why someone made a decision, we can't safely change it or conclude that they were wrong. So how do we become intimate? How do we become intimate with it? We look at the resources that the manufacturer gave us. We contact the manufacturer and we ask them, hey, I'm combining these 2 sources. Can you answer some questions for me? We open up Map3D, RumiQ Wizard, Crosslight, these kinds of things. And you can open up Tracebook, and maybe you can find measurements for these speakers, and you can practice combining them in your audio analyzer. Okay, you guys, thanks so much for hanging out with me here today. I hope this has been helpful for you. I'll go back and see if there were any questions that I missed in the chat. But if you would like me to do more of these kinds of live streams, just let me know, and let me know what questions you want me to answer, or what is a big topic that you would like me to try to cover. All right, thanks a lot, you guys. So I hope everybody gets a little bit of a break during the holidays, and probably see you next year. Thanks.